So for our calculations portion of the CBR test, first here are the several dimensions and weights of the empty mold, the mold of the soil, the diameter of the mold, the height of the mold, the water content. The least count of the deflection dial gauge is 0.001 inches per division, and the PRC of the proving ring is 3.37 pounds per division. So the test that you guys saw in the video, here are the deflection dial gauge readings. You can see from 0 to 300 there is an interval of 25. After that, from 300 to 400 the interval is 50, and after 400 we have an interval of 100 to straight to 500. And these are the corresponding load values that we had determined while we were observing the deflection dial gauge readings. These are the corresponding load dial gauge readings. So multiplying this entire cell with 0.001, we have the penetration of the plunger over here, and multiplying this entire column with the PRC, we have the load applied over here. So what we have to do is we have to plot a graph of our penetration on the x-axis versus our load on the y-axis. So scatter, select the data, add. Now your x-axis will be this, the penetration of the plunger, and your y-axis will be the corresponding load. And this is your graph. You can add the axis titles, penetration inch, and over here you can add load in pounds. Load. So this is our graph over here, but you can see that if we zoom in on the graph, at the start our curve is concaving upwards. So let me just remove the point so that you can get a better look at it. We just go to markers, marker options, and none. You can do this for all the markers as well. None. Now you can see the curve is concaving upwards. So this is not following at the start the trend of our load versus settlement curve or load versus penetration curve. So we just have to draw a tangent at the part of the concave where the part of the curve that's concaving upwards. And how we'll do this is you have these points over here, 0.25, 0.05, and these ones over here. So you just type them down over. So we want to know if we draw a tangent at this point in the curve where the slope is the greatest, then where would it intersect with the x-axis over here? So how we do that is that on Excel we can draw a trend, our known y's, and our value at which we want to find out is when this is equal to 0. So 28. So this is 0.1718. So let me just draw that for you over here. You can see now that a tangent has extended from this point where the slope was the greatest in the concave of the curve, and it's touched down to 0 over here. So now this point will be our new 0. As you can see, it's currently at 0.075 and a little below 0.02. So this point is now our new 0. And from here, we have to find the values of the load corresponding to 0.1 inch penetration and 0.2 inch penetration. So how you can readjust your graph is that you'd have to draw another column over here is equal to, okay, this will be 0, and then the next ones will be is equal to this minus this, and just put a dollar over here so that the value doesn't change when you drag it down. Now once you've done this, select the data, edit your first series. Now your x will be this. When you do that, your entire curve shifts back by this amount. And this part is parallel to this part over here. So you can just delete this one. And now it's pretty straightforward. You can measure 0.1 inch. You can extend a line from here and see the corresponding load value. And the same for 0.2 inches. Like if we zoom in a bit, we can see that at 0.1 inches, it is roughly 420. And at 0.2 inches, it is, sorry, it's 440 over here. And at this point, it is nearly 720. So 420 and 720. So these are our load values at 0.1 inch penetration and 0.2 inch penetration. So how now we will determine the CBR value at 0.1 inch and 0.2 inch. This is our standard load at 0.1 inch penetration, and this is for 0.2 inch penetration. So CBR is equal to test load over standard load. So test CBR, so this will be at 0.1 inch penetration, it was 420. So 420 divided by this into 100. Your CBR is 14 for this, and for the next one, it will be 720 divided by 4500 into 100, and that will be 16. So your CBR is 14% for 0.1 inch penetration and 16% for 0.2 inch penetration. And using these values, you can then calculate the pavement thickness that you're designing. And that's all there is to the calculations in this.